Hi, hello, good afternoon. This is Maruti Prasad Satluri. This is Maruti Prasad Satluri. Welcome to Unacademy YouTube channel, all of you. This is Maruti. I have more than 13 years of experience in teaching chemistry for EAMCET, JEE and NEET students. Please subscribe this channel and like it as well as share it. Okay, don't forget it. And one more important thing I want to discuss here is the subscription page on behalf of Unacademy. If you are a subscriber, then there is no problem. If you are not taking any subscription, please take the subscription immediately. The benefits are premium content at affordable price, structured live courses will be there with dedicated live doubt clearing sessions, and so many number of quizzes at regular intervals for getting self-analysis of yourself, and so many number of batches for complete preparation of the syllabus. And we will discuss test series for daily practice papers, full-length mock test with complete analysis, and by taking single subscription you will get unlimited access. The access unlimited access are 20 plus top educators, 10 plus batches, 250 plus courses, 2000 plus lessons, and many more will be added every day. Many more will be added every day. Maruti Live is my code. Once you are applying my code, you will get 10% of instant discount. Okay, everything is under single plus subscription. And one more important thing is Unacademy is giving two best plans for EAMCET 2021 aspirants. 12 months plan, 6 months plan. 12 months plan is 12,375, whereas 6 months plan is 10,125 rupees. It is 1000 approximately and it is 1600 rupees approximately. Multiple batches are launching every month. If you are applying my code Maruti Live, you will get 10% of instant discount out of the total amount here. And just now I mentioned earlier, like as here, two comprehensive batches are going on. Two comprehensive batches are going on. One is PCB, Physics, Chemistry and Biology, and another one is for PCM, Physics, Chemistry and Mathematics. It is a 6 months full syllabus plan and it is 8 months plan. If you are not enrolled now, please enroll now immediately. Okay. And this is the last one, Telugu batch. This Telugu batch has already started on 12th of October 2020. If you have not enrolled, please enroll now immediately. It is also for TS and AP EAMCET 2021. You can learn from best educators for EAMCET 2021, and detailed explanation in Telugu language is for better understanding of all of yourself. It is a very better understanding. And complete syllabus coverage will be there. Wherever necessary, we will give the tips as well as tricks to you for time save as well as for better score in the examinations. Okay. And see here, the monthly trial plan is 2250 rupees. Once you are applying my code, you will get 10% of instant discount. This is my code. Maruti Live is my code. That's all. Yeah, let us start. Let us move on to our interesting topic, that is 7th VIIA Group Elements chemical properties. Already we have seen so many number of chemical properties in the previous session. Already we have seen the reaction with water molecules, reaction with oxygen, reaction with metals. Already we have seen. Now today we are going to discuss about the reaction with halogens. The reaction with halogens. It is most important topic for us. It is most important topic. Halogens. Reaction with halogens. Let us see one by one. Reaction. Our important topic is reaction with halogens. All of you be ready. Okay. Halogens are again reacts with another halogens. That is the peculiarity in this case. Halogens are again reacts with another halogens. That is the peculiarity. Suppose if you take a halogen like a halogen like A, it again reacts with another halogen. Consider that it is halogen 1. Consider that it is halogen 2. So if two halogens are combined together, and it will forms a binary compound. It will forms a binary compound. This binary compound is called as interhalogen compounds. These are all called interhalogen compounds. Very important with respect to EAMCET point of view. What are interhalogen compounds? One halogen reacts with other halogen. It will form a binary compound. That binary compound is called as interhalogen compounds. That's all. That binary compound is called as interhalogen compounds. So let us see the examples of interhalogen compounds and its electronic state, hybridization, as well as oxidation numbers, etc. Not oxidation numbers, we will see the structures also. Okay, and these interhalogen compounds can be classified. So many number of interhalogen compounds will be produced. So many number of interhalogen compounds can be produced. Here are the classifications. See, listen carefully. Here are the classifications. The first one is AX1 type, and the second one is AX3 type. I think in the last session I have discussed the same thing. AX3 type, and the next one AX5 type, and the last one is AX7 type. Okay, these are called interhalogen compounds. Different interhalogen compounds. These are all. Okay, and I have already discussed about the most examples which are relates to individual interhalogen compounds in the last session. Okay, so now I'm going to discuss about the hybridization concept of all the interhalogen compounds. These are all very important for us. Hybridization of interhalogen compounds. Hybridizations, very important it is. See here, the first one is AX1 type. I'm taking AX1 type here. Okay, AX1 type. In this case, in this AX1 type, I am taking one example like CLF. What is the central atom here? Cl is the central atom. Okay. What about the Z value? 17 is the Z value. 17 is the Z value. Just write the electronic configuration. Neon is over. 1s2, 2s2, 2p6 is over. Then 3s2, 3p6 and 3d 0. 3s2 it is. 3p6 it is 1 2 3 4 5, sorry, not 3p6, it is 3p5. cs2 3s2 3p5 and 3d 0 1 2 3 4 and 5, 3d 0. Yeah, suppose if the chlorine wants to react with fluorine, how many fluorines will be attached to the chlorine? Only one fluorine have been attached. So 1 to this one chlorine should have one unpaired electron in its outermost. See, already one unpaired electron is there. So definitely it will have what type of hybridization? sp3 hybridization. sp3 hybridization. It should participates. No, Jasmita, it is a second year session. It's a second year 7th group. Jasmita, okay? It's not first year, it's second year. sp3 hybridization will be produced. So it undergoes sp3 hybridization. Very simple. Okay. Right, then see here sp3 hybridization it is. So once you are taking, once you are saying that the chlorine is undergoes sp3 hybridization, you know, one s orbital and three p orbitals are combined together and forms 4 sp3 hybrid orbitals. But out of the 4 sp3 hybrid orbitals, 1 2 and 3 hybrid orbitals are having 3 lone pairs. One is having only one unpaired electron. See here, it is one hybrid orbital, it is second one, it is third one, and it is fourth one. Consider that it is chlorine. Okay, so out of the four hybrid orbitals, 3 hybrid orbitals are having 3 lone pairs and one hybrid orbital is having unpaired electron. This unpaired electron will binds up with one p orbital in the fluorine. One p orbital, it is chlorine, it is fluorine. Only this will forms the sigma bond. These three will not forms any sigma bond. This only will form the sigma bond. So this is a bond pair. These three are lone pairs. So here lone pairs are 3 and bond pairs are 1. 3 lone pairs and one bond pair. 3 lone pairs, 1 bond pair means it is nothing but equals to tetrahedral with 3 lone pairs. This is the structure. What is the structure of it? The structure is 3 lone pairs and 1 bond pair. 3 lone pairs and 1 bond pair. Or otherwise simply it is called linear shape. Simply it is called linear. So tetrahedral with 3 lone pairs or linear. Tetrahedral with 3 lone pairs. It is, see here, it looks like a tetrahedral. It looks like a tetrahedral, but it is not a tetrahedral actually. It is a tetrahedral with 3 lone pairs, or simply it is called linear. That's all. This is all about an interhalogen compound like AX type. AX type of interhalogen compound is over. Likewise, you can do AX3 type, AX5 type and AX7 type. Okay. Coming to the second one, that is AX3 type. AX3 type. That means ClF3. This is the example for us. Let us start the hybridization concept. Like as in the previous, chlorine equals to 17. Like as in the previous, as it is. There is no deviation at all. Chlorine Z equals to 17. So neon 3s2, 3p5 and 3d is 0. 3s2, 3p5, 1, 2, 3, 4, 5, 3p5 and 3d 0. Okay. But here one chlorine can binds up with the 3 fluorines. That means it should have 3 unpaired electrons in its outermost. So how it can have 3 unpaired electrons? Actually it is a ground state. In ground state it is having only 1 unpaired electron. But chlorine requires 3 unpaired electrons. So it should have how many times it should excite? Yes, only in first excited state. Only in first excited state it can have 3 unpaired electrons. 3s2, 3p4, 1, 2, 3 and 4. 3p4 and 3d1. 3d1, yes. So in first excited state, what will happen? One electron in the p orbital of the chlorine is jumping towards the d orbital. So it can have now 1, 2 and 3. 1, 2 and 3. Okay, 3 unpaired electrons will be there. So chlorine should participate in which hybridization? 1 s orbital and 3 p orbitals and 1 d orbital. So all the orbitals are binds up and it will participate in sp3 hybridization. sp3 hybridization. That's all. sp3 hybridization it is. Is it clear? So sp3 hybridization means 1 s orbital, 3 p orbitals and 1 d orbitals are combined together and forms 3 plus 1 4, 4 plus 1 5. 5 sp3d hybrid orbitals will be produced. 5 sp3d hybrid orbitals will be produced. Out of these 5, 1, 2, 1, 2, 2 lone pairs are there, 3 unpaired electrons are there. These 3 unpaired electrons are binds up with 3 fluorines. These 3 unpaired electrons are binds up with 3 fluorines. 3 fluorines to bind up होते. Then what is the structure? What is the structure? sp3d means 3 plus 1 4, 4 plus 1 5. That means it is trigonal bipyramidal with tell me, trigonal bipyramidal with how many lone pairs? With 2 lone pairs. Trigonal bipyramidal with 2 lone pairs. I am writing here. Trigonal bipyramidal with how many lone pairs? With 2 lone pairs. With 2 lone pairs. Trigonal bipyramidal with 2 lone pairs, right? Or otherwise simply it is called which shape? T shape. See here, it is Cl. 3 fluorines are there. 1, 2 and 3. 3 fluorines are there. So in this 2 lone pairs are there. So it is 1 lone pair and it is the other lone pair. It is the other lone pair. It is other lone pair. Okay, 3 bond pairs are there. 2 lone pairs and 3 bond pairs. 2 lone pairs and 3 bond pairs. 2 lone pairs and 3 bond pairs are there. So whenever we are saying that it is 2 lone pairs and 3 bond pairs, we can say that it is T-shape. It is a T-shaped molecule. That's all. This is called all about AX3 type. AX3 type. Coming to the next one. AX5 type. AX5 type. Okay. AX5 type. Let us see. AX5 type it is. AX5. The best example is ClF5 is the best example. ClF5. Again, I am saying the same thing. Cl equals to 70, Z equals to 17, neon, 3s2, 3p5, and 3d0. 3s2, 1, 2, 3, 4, 5, 3d0. Okay. So now, here the chlorine is bind up with how many fluorines? 5 fluorines. So it should get a second excited state. In second excited state, one electron will goes like this and second electron will goes like this. So totally there are 1, 2, 3, 4, 5 electrons. See here. Two electrons are there here. In the p orbital, 1, 2, 3 electrons are there. In the d, 2 electrons are there. So totally there are 5 unpaired electrons are there. So it can participate in sp3 d2 hybridization. It can participate in sp3 d2 hybridization. sp3 d2. So once it undergoes the sp3 d2 hybridization, sp3 d2 means 3 plus 2 5, 5 plus 1 6. 6 means it is octahedral, right? It should be in octahedral. So the shape or structure should be octahedral with how many lone pairs? See here, only one lone pair is there here. So octahedral with how many? Octahedral with one lone pair, or simply it is called square pyramidal. It is called a square pyramidal. See here, it is chlorine. It is chlorine. 1, 2, 3, 4. In 4 corners of the square planar, 4 fluorines are there. 4 fluorines are there. This is the 5th fluorine. But out of which one is lone pair. One lone pair is there. It looks like as an octahedral, but out of the total structure, one lone pair will be there. So it is called a square pyramidal. It is called as square pyramidal, right? And coming to the last one. What is the last one? AX7 type. AX7 type. The best example for AX7 type is IF7. IF7. Let us start the iodine. Okay. What is the atomic number of iodine? 53. Iodine atomic number is 53. So 5s2, 5p5. Iodine Z equals to 53. Z equals to 53. You can write like this. Iodine. So krypton 4d10, 5s2, 5p5, 5d0. So this is 5s2, 1, 2, 3, 4, 5p5 and 5d0. 5d0. But see here, one important thing is here iodine can react with how many fluorines? Please tell me anyone. Iodine can react with how many fluorines? This is the example IF7. So iodine can react with how many fluorines? Tell me, anyone? Iodine can react with 7 fluorines. Iodine can react with 7 fluorines. Okay. So that means in the outermost of the iodine, how many unpaired electrons should be? How many unpaired electrons should be? It should have 7 unpaired electrons. If it wants to have 7 unpaired electrons, it should get excited in third excited state. Not in the first and second. It should get third excited state. In the third excited state, what will happen? One electron will goes to D, second electron will also goes to D, and this s orbital electron also will goes to D orbital. So 1, 2 and 3. So all the lone pairs, all the paired electrons are totally gets deviates, dissociates, and all are converted to single electrons. So what is the third excited configuration? 5s1, 5p3 and 5d3. It is 5s1, sorry, it is 5s1, okay, it is 5p3, it is 5d3, it is 5s1, it is 5p3 and it is 5d3. So now if the iodine wants to react with 7 fluorines, the iodine should participate in which hybridization? 1 s orbital, 3 p orbitals and 3 d orbitals. So it should participate in sp3 d3 hybridization. sp3 d3 hybridization it should participate. So once it participates in sp3 d3 hybridization, sp3 d3 hybridization, what is the shape of it and how many hybrid orbitals will be produced? sp3 d3, so 1 s orbital and 3 p orbitals and 3 d orbitals are participates together and it will produce 3 plus 1 4, 4 plus 3 7, 7 sp3 d3 hybrid orbitals will be produced. How many lone pairs are there here? Just see here. Is there any lone pair? No, there is no lone pair at all. All are unpaired electrons. All are unpaired electrons. There is no lone pair at all. So, lone pairs are 0 and unpaired, and that means bond pairs. Unpaired means bond pairs. Bond pairs are 7. So 7 bond pairs and 0 lone pairs. What is the structure? 7 bond pairs and 0 lone pairs. What is the structure? The structure is pentagonal bipyramidal structure. The structure is pentagonal bipyramidal. How the structure should be? How can we write the structure? Pentagonal bipyramidal. See here, it is iodine. It is iodine. This is one fluorine, second one, third one, fourth one, and fifth one. So 5 fluorines have been attached within the plane. And another fluorine, sixth fluorine is above the plane, and the seventh fluorine is below the plane. So there are 7 fluorines which have been attached to the iodine like this. It is a pentagonal bipyramidal structure. It is in the shape of pentagonal bipyramidal structure. That's all. These are all about interhalogen compounds. These are all about interhalogen compounds. That's all. Very simple. These are all very simple. Simple concept it is. I think I am clear with respect to interhalogen compounds, right? And in the next session we will discuss about the chemical reactions. That means preparations of interhalogen compounds and the properties of interhalogen compounds also we will see. Now we are going to discuss the another important concept, that is anomalous behavior of fluorine. Anomalous behavior of fluorine we are going to see now. We are going to discuss now. Anomalous behavior of fluorine. See, not only the fluorine, if you observe the groups, like any group, the first element in all the groups, are exhibiting this anomalous behavior. Why the first elements in all the groups are exhibiting anomalous behaviors? Is there any reason? Yes, there is a reason. Generally, the first elements in all the groups, are having smallest atomic size. First elements in all the groups are having atomic size is very less. In this case also, fluorine is very smallest atom. Fluorine is smallest atom. So based on the size of the atom also, we can guess whether it exhibits anomalous behavior or not. So out of these four, definitely fluorine can exhibit anomalous behavior, no doubt about it. And in the same way, more electronegativity. In the groups, the topmost element is exhibiting more electronegativity. It is having more electronegativity. So out of the fluorine, chlorine, bromine and iodine, fluorine is having a most electronegative. Fluorine is a most electronegative atom. So as it has most electronegativity, again it can exhibits the anomalous behavior of the 7th A group elements. Compared with other 7th group elements, fluorine can exhibit anomalous behavior. Fluorine can exhibit anomalous behavior. And one more important reason is no vacant d orbitals. Here the fluorine does not having any vacant d orbitals, because fluorine is having only how many orbits? 2 orbits. But from chlorine, bromine, iodine, definitely there are some d orbitals. Vacant d orbitals are present, because from chlorine, which orbit will start? Third orbit will start. The d orbitals are present only from third orbit. That's why chlorine, bromine, iodine are having d orbitals, vacant d orbitals, but the fluorine cannot have the vacant d orbitals. That's why also fluorine is getting anomalous behavior than the remaining three elements. That's all. So as of these three different reasons, the fluorine is exhibiting anomalous behavior compared with the remaining all 7th A group elements. Of course, one more important reason is also there, that is low bond dissociation enthalpy. Low bond dissociation enthalpy. Maximum of you may confuse that the fluorine is having highest bond dissociation enthalpy. Maximum of you may confuse like that, because the fluorine is smallest atom. So the bond length is very less. So once the length is very less, the bond dissociation energy may be high అని అనుకుంటాం, but it is not correct, because fluorine is very smallest atom. Whenever the fluorine is the smallest atom, see here, you know very well fluorine is having 3 lone pairs and 1 unpaired electron. This fluorine is also having 1 unpaired electron and 3 lone pair of electrons. This is the bond. But when the fluorines are closely combined with each other, then what will happen? These 3 lone pairs of the fluorine and these 3 lone pairs of the another fluorine may have some repulsions. Inter-electronic repulsions will be possible. Inter-electronic repulsions. Inter-electronic repulsions will be possible. Yeah, Purnasai, very good afternoon. Very good afternoon, Purnasai. But you are too late. Already the time is over. interelectronic repulsions will be possible. So thereby the fluorine and fluorine is having maximum amount of distance, thereby you can easily cut it. So the bond dissociation enthalpy is very less. So due to these four important reasons, these are all reasons. Basing on these four important reasons, the fluorine is having anomalous behavior compared with the remaining elements of the 7th A group elements. That's all. Okay, today evening at 5 to 6 o'clock there is a special class on atomic structure, and there is a other special class at evening 7 to 8 on chemical kinetics. If you have any interest, please come to my special classes. Until then, keep watching my videos. Thank you. Bye bye.